host at ICSE in one shot. So how is life going on? All well, sorted. I welcome to your once another wonderful session which you're gonna enjoy. So stay till the end, okay? And do remember to subscribe to the channel, hit the like button, and share it with your ICC buddies. And let me know in the comment section what are the rectifications do I need to do to my channel. In this channel, we prescribe for the content of Selina ICC Physics, Chemistry, Biology, and live interactive Menti quizzes. So do everything to just help me grow my channel, and thus we go towards a different new level of learning. So without any further delay, let's begin with the session. Let's go.
Hi guys, how are you all? Welcome back to another session. As many of you requested me to bring up the test paper series, so let's begin with the ICSE Selina 2018 paper which we have solved. So as we know, that's a common instruction for everybody that we have to attempt two sections. One is our compulsory section and the other one is our choice section. Yeah, surely. In this section one we have got 40 marks compulsory, and the second section which I'm going to show you, that too has got 40 marks, and that is our choice which we have to make. So let's answer the first question one, which is a let's begin. But before beginning the session, I would ask all of you, if you haven't subscribed the channel, please do subscribe the channel and hit the like button if you case you think that I am making the content up to the mark, and share it with your ICC friends to help them out. Okay, so let's begin. Our first question is given to us as question number A. State and define the SI unit of power. And how is it the horsepower related to the SI unit of power? So first we would write that the SI unit of power is watt, and it is defined as the power spent when 1 joule of work is being done for 1 second. That's your definition. Then for the second question you would write 1 horsepower is 746 watt. That's your answer. Okay, next the question states that state the energy change as in case of the following while in use: an electric iron, and there is a ceiling fan. Okay, so in case of electric iron, the electrical energy changes into heat energy. Similarly, the electrical energy changes in case of mechanical energy for a ceiling fan. Next, this question we don't have because it's belonging to lever, so please cross that. Next, it's given D. What is the velocity ratio of velocities of light of wavelengths 4000 angstrom and 8000 angstrom in vacuum? 1:1. Why is it so? So in vacuum, the light of each of the wavelength travel at the same speed. That is, the speed of the wavelength of 4000 angstrom is same as that of the light of 8000 angstrom. As in this case, we take it red and violet light respectively. Okay, so that's fine. Now, which of the above wavelengths has got a higher frequency? Obviously, the more the frequency, the less would be the wavelength for it, because they're inversely related. So obviously 4000 angstrom would have a higher frequency. Next question is given to us: why is the motion of a body moving in a constant speed around a circular path said to be accelerated? Simple, you would say the motion of the body moving in a constant speed around a circular path is said to be accelerated as because the direction keeps on changing. That is, the tangential velocity is there in this case, as a result of which it is an accelerated motion. We would write this. Now next question is: name the unit of physical quantity denoted by 2k by v square. Now at the first glance you would think, what is this? Oh my god, nothing. You would just write the formula of kinetic energy, which is kinetic energy equals to half mv square. Okay, then you would put m this side and put the all the other half would come up and make it 2k, and v square would come down. So ultimately the quantity will be mass m, which is in kilograms. Okay. Next question, number 2. The power of the lens is minus 5 diopters. Find its focal length. Name the type of lens. These two are our questions. So first answer would be find the focal length, right? So what we know is when the power is given to us, it's in meters, right? So we need to convert it into centimeters. Or if it is if we are keeping it as the same, then it would come to us in meters, the value. So f equals to 1 by p. So ultimately 1 by minus 5, which is it minus 0.2 meters, or we can say minus 20 centimeters. Okay. And what is the lens? We obviously know that when the power is negative, it's a concave lens. Myopics, support me, because myopia is the treatment to this. Next question. See, I just took the it's getting blurred or somewhat. Okay, that's fine. I thought there's a deflection of the focus of this thing. So let's go forward. See here, it's given question number B. State the position of the object in front of a converging lens if it produces a real and same size image of the object. Obviously, you need to put it at the center of curvature to obtain real inverted and image of the same size. Okay. Next question is, it is used in a magnifying lens. Magnifying lens, we know that there is only one instance when a converging lens or a convex lens can produce a erect image. So that's in between focus for center focal point and our optical center. So that is the case. Written it. So then we have C2, which is states that state the relationship between the critical angle and absolute refractive index. Critical angle IC is sine of inverse of 1 upon mu, or sine IC you can tell 1 upon mu, because they're inversely related, no? Now, which color has the higher critical angle? Now you only tell me. Red has got a lower refractive index than violet or any other light. Okay. So obviously, since it is in inverse relationship with the sine of angle of incidence, the refractive index, so ultimately the thing is that the critical angle of red should be higher than the other. Since others are higher than this, so in inverse, red would get the higher amount for the critical angle. Next question you don't have, because it's related to scattering. So let's proceed. Now this question is very much understandable. Now the question states the following diagram shows a 60-degree, 30-degree, 90-degree prism made up of critical angle 42-degree. Copy the diagram and show the path of the incident ray AB which emerges out of the prism, making an angle of incidence at each surface. Now you see here, this is the perfect completed diagram of this. In first instance, since it falls perpendicularly, it would go as it is. Then at this aperture, since this is 30-degree, this would become 90 and this would become 60. Since it is a normal, this becomes 30-degree. So here what it is said, the critical angle is 42. What happens when the angle of incidence is lesser than the critical angle? Surely, you got it right. It undergoes, yes, refraction. So it gets refracted. Since it goes from denser to rarer, from glass to air, it diverts away from the original path. So that is the diagram you need to do in your exam. Okay. Question 3 now. A displacement distance graph of two sounds A, B are traveling the same medium as shown in the figure below. So this is a graph which will be given to us. Now state two sound waves and compare their amplitudes and wavelength. From the above figure, we can see that the amplitude of wave A is 20 centimeter and the wave B is 10 centimeter respectively. So therefore, the ratio would come up to be as 2:1. Now, in case of wavelength, you see wavelength of A is just if you consider the distance to be x, this x, this path is considered to be as x, and the wavelength of B is considered to be as double of this, since B takes this long to complete one wavelength. So ultimately the ratio is gonna come as 1:2. Next question. You have given three resistors each of value 2 ohm, 3 ohm and 5 ohm. How will you join them so that the total resistance is more than 7 ohm? Very easy. We know that series arrangement is the one where we're gonna get everything all together maximum. This is the most easy question you can see. See, you have to draw the diagram as it is given over here. This simple diagram you need to draw and calculate the equivalent resistance. Now, which we are studying now is that the equivalent resistance R is R1 plus R2 plus R3, because they are in series, right? So it becomes 2 plus 3 plus 5, ultimately 10 ohm is your answer, correct answer. Now nuclear fusion fission you don't have, so cut off this question. Next question is, what do you understand by the free vibrations of a body? Okay, so what do we mean by that? The periodic vibrations of constant amplitude and frequency in the absence of any other external medium, that is only the restoring force acts on the body, they are called to be as free vibrations. Okay, now why does the amplitude of a vibrating body continuously decreases during a damped vibration? It's just because the amplitude gets continuously decreased because of the loss of the energy against the damping forces, which is the resistive forces such as air friction you can say. Next question we don't have, cut off the E. Next you come to question number 4a. So how can a temperature in degrees Celsius be converted into SI units of temperature? How to do that? Very simple. Whatever it is in the value of degree centigrade, just add to it 273 to get the temperature in Kelvin. As simple as that. Okay. Next question you don't have because it's related to specific latent heat numerical. So simple numericals also you don't have from the latent heat concept. So strike it off. Let's move. Now identify the following words used in the household circuit. Wire, which is called a phase wire. Phase wire, what we know? Phase, which is in phase, live wire, which brings in current to our home in the domestic circuit. Okay, the next wire is connected to the top terminal of a uh, 3 pin socket, so it's the thicker one. Remember, earth wire, surely. And that is, what are isobars? Question number D. Isobars are the atoms of the same mass number but different atomic number. Okay, and give one example. Sodium with mass 223 and magnesium with mass 223. So both of them with 23 mass number each, but their atomic number differ by 1 each. So it's sodium for 11, magnesium for 12. Okay, next, state any two advantages of electromagnets. So this also you don't have. Let's go forward. Now we are entering into the section B. So please pay attention to this section, because this section is a bit critical and it analyzes your brain to how much you have studied the concepts deeply. Okay, let's go forward. Now it states question number 5a. Derive a relationship between the SI and CGS unit of work. Okay, so its SI unit of work is joule and CGS is time. So work done is force into displacement. That's the particular definition. So 1 joule equals to 1 Newton into 1 meter. 1 Newton we know is 10 power 5 dyne and 1 meter is 10 square centimeter. Ultimately it gives me 10 power 7 dyne centimeter, which is 10 power 7 erg. Ultimately 1 joule gives me 10 power 7 erg. This is our relationship. Next question is, a force acts upon a body and displaces it by the distance of s in the direction of an angle theta and the direction of the force. What should be the value of theta to get the maximum positive value? Maximum positive work. So maximum positive work is theta, cos theta, which is that you need to get that 1. Then only it would come the maximum. So when does cos theta come 1? When theta's value is 0 for cos theta, since cos 0 degree gives me 1. So that's your answer. Easy. Now here gives me a half meter rod is pivoted at with the center at the two weights 20 GF and 12 GF, which is suspended at a particular perpendicular distance of 6 centimeter and 10 centimeter on the pivot respectively, and that's shown given. So which of the following causes a clockwise movement? Very simple. You need to get it in your head that 12 GF, this one rotates in the face of the clock, so this end is gonna move it and produce the clockwise moment. Similarly, is the rod in equilibrium? Yes, we need to calculate that one. You can't directly tell it, no, that this one is in equilibrium or no. That will be wrong. So you would state that since the clockwise moment is 20 GF into 6 centimeter, so 120 GF centimeter is equal. In this case, it is equal. So the rod is in equilibrium. Now, next question states to me that the direction of the 20 GF force is reversed. Will the magnitude of the resultant moment of force on the rod? So you need to calculate that. You would write on reversing the direction of force 20 GF will also produce the clockwise moment, and total clockwise moment will be 20 GF into 6 centimeter plus 12 GF into 10 centimeter. Ultimately, it is going to come 20 to 40 GF centimeter. So that's your answer. Next question is given to us that draw a diagram which shows a block and tackle system having a velocity ratio 3 marking the direction of load, effort and tension. So when happens this 3 velocity ratio we get? 2 in the block, 1 in the tackle. So you have to draw appropriately this diagram. 2 in the block, 1 in the tackle, and like this you have to rotate it up like this. Here is the load, here is the effort. They have forgot to give the mark the tension. You would mark it tension upwards. Okay, everywhere, here, everywhere you will mark it tension. Okay, all right, but don't take tension. That is the thing. Let's go forward. The pulley system draws lifts a load of 150 Newton and an effect of 60 Newton is applied. Find the mechanical advantage. So here load is given to me 150 Newton and effort is 60 Newton. So mechanical advantage comes to me load upon effort, which is 150 upon 60 Newton is 2.5. The pulley system is not ideal itself because we cannot obtain more than one value in case of mechanical advantage, because for an ideal machine which is itself difficult to obtain, that is maximum one, how can you get more than one? 2.5, not possible. Next question. Question number 6. It states a ray of light XY which passes through a right-angled isosceles prism as shown alongside. What is the angle which the incident ray deviates and emerges out of the prism? It's 90-degree, obviously. Angle of deviation is angle at which the emergent ray makes with the incident. So here it's striking over here and here is emerging out. So ultimately angle is 90-degree. 90 degrees is the answer. Name the instrument where is the action of the prism is put into use. Prism, obviously we use it in the periscope. So this is the application of the periscope. Which prism surface will behave as a mirror? Surface AB, because that's the literally inverted image it's gonna produce. And now it is object AB which is placed at O and F1 on the principal axis of a converging lens as shown in the diagram. Copy the diagram and produce the image. Since it is between F focal point and optical center, it is gonna produce the virtual erect and magnified image. So you will modify this and you would copy this diagram out. Okay, an object is placed at a distance of 12 cm from the convex lens of focal length 8 cm. Find the position of the image and nature of the image. Simply you are going to put the lens formula 1 by v minus 1 by u is equal to 1 by f. From there 1 by v would come and you would come to be 24 centimeter. It will be 24 centimeter behind the lens since it's positive. Image would be actually really real, inverted, magnified. This they have made wrong. There should have been written here magnification, m equals to v upon u. So v comes to me 12 and u is 12, 24, and that is 12. So v upon u comes to me 2, which is magnified image. Correct. Done. Draw a diagram labeled here and produces an inverted image. So this is the case when you are using a right angled isosceles prism and you are obtaining an inverted image which is erected. Inverted image which is erected. QP erected as P dust Q dust. So this is the thing. Now in this question number B, we are given that the diagram given below shows a wire stretched over a sonometer. Stems of two of the vibrating strings is touched to a wooden box of sonometer. It is observed that the paper rider present on the wire flies off from the stem of the tuning fork B when touched by the wooden box, where the paper just vibrates when the stem of the vibrating tuning fork A is touched by the wooden box. So this phenomena, what is this phenomena? Surely it is the phenomena. Name the phenomena when the paper rides just vibrates. So it is the answer that the tuning fork A produces the forced vibrations due to which the rider vibrates. That's your answer for the first question. Next, you are given that the tuning fork B produces resonant vibrations, as in the case of which the rider actually flies away. So that is the case which you need to understand. Okay. Next is given to you. Why does the paper rider fly off the stem of the tuning fork B, which is touched by the box? Now, the frequency of the tuning fork B is equal to the natural frequency of the wire. That is the first definition of the resonance. So it vibrates with a larger amplitude, as a result of which it flies away, which happens in the case of resonance. So you need to keep that in mind. Now, this question is a very common question, stating a person is standing in the seashore. An observer of the ship, which is anchored in between a vertical cliff, and a person on the shore fires a gun. A person on the shore hears two sounds 2 seconds and 3 seconds after seeing the smoke of the fired gun. If the speed of the sound in the air is 320 meters per second, then calculate distance between the observer and the ship and the person on the shore, distance between the cliff and the observer on the sea. So in this case, we are considering D1 as the distance between the observer and the ship on the shore, and first the sound heard by the person, this person would be T1, which is 2 seconds, will be the direct sound which is heard by the fire of the gun. We would get V is equal to D upon T, because here no echo is there, simply the sound is coming to this person, direct sound, and one would be echoed from here to here. So in this case, so 320 is equal to D1 by 2. Ultimately, D1 is 640. This distance is 640 meters. Next question is, second sound heard by the person at the shore. The echo will be heard after the reflection of the cliff. Since the sound heard 2 seconds after the observer, so that the time taken to reach the observer is 3 seconds minus 2 seconds is 1 second. Since this time is 2 seconds, and ultimately from here, this time is 3 seconds. Ultimately, echo time would be 1 second. Now let the distance, here it is echo, so you would use the formula of echo, V is equal to 2D upon T. So ultimately D2 would come me as 160 meter. This you need to frame and write it in your answer paper, answer sheet. Next question 8. A part is given. A fuse is rated 8 amperes. Can it be used with an electrical appliance rated 5 kilovolt and 200 volt? Give a reason why. Here, for these type of questions, you need to use the formula P is equal to IV, where I, current drawn, is 25 ampere. Now, if we are putting the appliances of itself 25 ampere and a safety device of 8 ampere, ultimately the thing is that the system is gonna blow off and there will be short circuiting and chances of fatal electric shock. So ultimately it's a loss for the customer whosoever buys it. So you need to be very good in domestic circuit for these sums. Joking. Don't take the joke seriously. I'm being very practical. See, don't take these jokes seriously, man. This is not at all a serious thing. Let's go forward. Name two safety devices which are connected to a household circuit. Switch and fuse. Easy. Now here in this, find the equivalent resistance. This, if you are not practicing well your maths in current electricity, you would face it difficult. But in case if you practice, it's gonna be very easy. See, these solutions you're gonna see, I'm gonna tell you simply. So here it's 6 and 3 ohm in parallel. So ultimately 1 by R1 is 1 by 3 plus 1 by 6, which gives me 1 by R1 is ultimately gonna calculate and give me 2 ohm. Okay, and R2 is, you would calculate it in a similar way, 1 by 4 plus 1 by 12, and ultimately give you 3 ohm. Now these two are in series. Ultimately the total equivalent resistance in the circuit is gonna be 3 plus 2 gives me 5 ohm. Got it? The resistivity of the wire doesn't change with the change in thickness of the wire. This question is very important. State whether it changes, resistivity changes with the thickness of the wire. No, mark it, very important. Mind it, resistance increases with the thickness of the wire and not the resistivity. Okay, next. Question number C is given to me. An electric iron is rated 220 volt and 2 kilowatt. Okay, the iron is used for 3 hours daily. Find the cost for it running in 1 week, but the cost is 4.25 per kilowatt hour. Now you see the data is here given is very wrong. Ultimately the answer is gonna come something else, and the cost also is going to come something else. It would gonna come as somewhat 128 point something rupees it would come. Mind, okay, this is not the correct answer because they provided the data wrong in both these statements. Next question, why is it the fuse absolutely necessary in the circuit? Obviously, if we, fuse is such a device which protects the circuit from getting overloaded. Okay, and that is the total power of the appliance is not exceeded, therefore excessive energy may damage the appliance. So in that way it is making practically the article safe from any sort of damage, that you get to understand. Okay, now question number 9, which is heat supplied to a solid changes into liquid. What change in the phase? Obviously we are putting heat solid to liquid, so it's gonna melt. During the phase, does the average kinetic energy of the substance increase? No, average energy doesn't increase. It remains conserved as it is, and therefore we don't see any change in temperature. And what is the energy absorbed? Although this third question is not in your syllabus, but you need to know that's the latent heat. Okay. So what is the difference between heat capacity and specific capacity? Now, thing is that heat capacity is the amount of heat energy required to raise the temperature of the entire body by 1 degree Celsius, but specific heat capacity, it requires a unit mass of the body. That is why heat capacity is formalized joule per Kelvin and SI units is joule per kg per Kelvin. This was the question for mathematical relationship between heat capacity and specific heat. Heat capacity equals to mass into specific heat capacity. Next question, this question we don't have since it is the specific latent heat. These things we are given and latent heat numericals we don't have, so you can strike it off. Not even question number 10. But yeah, B portion is there. It's saying an ore of uranium is found in nature containing 238 uranium 92 and uranium 235. Okay, although both of these isotopes are fissionable, it is found that experimentally one of these isotopes are more fissionable. Name the isotope which is more feasible. It is 235, which is easily feasible. And now the reason why it is so feasible is that uranium 238 is very possible only by fast neutrons, while the fission of uranium 235 can be done by slow neutrons. So that is why it is much more easy for 235 uranium to undergo the radioactivity by slow neutrons. Now you have to write a nuclear reaction when the uranium-238 emits an alpha particle to form a thorium nucleus. So what happens in alpha? Alpha can be denoted at this way. We know that is the alpha particle. So 4 mass it is, and 2 is the atomic number. So deduct from this to get thorium. 238 minus 4 gives me 234, and 92 minus 2 gives me 90. So that's done, practically done. Now which we are discussing, that is question number C. In this question, radiations given out from a source which is put subjected to an electric field in a direction perpendicular to the path which shown in the diagram. Find the show the path of the radiation ABC. Answer the questions related to that. Name the radiation B which is unaffected by the electrostatic field. Obviously it is gonna be gamma radiations because it is an electromagnetic wave, not any form of radiation as such. Why does the radiation C deflect more than A? Because beta, which that is the radiation C, is lighter than the radiation A, which is alpha. So that is why C deflects more than that of that. Because C is independent, it is a flight mass, it can easily choose its own way. Okay. Next is which among the three causes the least biological damage externally? It's going to be alpha, because alpha has got the highest ionization power, and a result of which it has got the least biological damage to the body. Next, name the radiation which is used in carbon dating. Obviously it's beta emission which is used in carbon dating. So with this we end the session of the 2018 physics paper for Selina. So if you like the session, please hit like the session and comment me down if you have any sort of doubt or any clarifications you need to make. I would be free over there, and do subscribe the channel if in case, and comment me down if you want whether you want the 2019 paper to be discussed in the similar way. With that I do. With this is Nijam Rizvi signing off for the session. Take care, stay healthy, bye, peace.